Hello, and welcome to this presentation, Understanding Amplitude Shift Keying. In this short presentation, we'll explain the basic concepts behind amplitude shift keying, as well as give some examples of how this type of modulation is used in real-world applications. As the name implies, amplitude shift keying, or ASK, is used to encode digital data by varying the amplitude of an RF carrier. There are two general ways in which we can implement ASK. The oldest and easiest method is simply turning the carrier on and off, which is how Morse code is normally sent. The other method is varying the amplitude of a continuous carrier between two or more different levels, all of which are non-zero. An example of this is near-field communications, or NFC. With very few exceptions, amplitude shift keying involves two states. Technically, this could be referred to as binary amplitude shift keying, but you're unlikely to hear the specific term used since almost all applications of ASK use only two states. The on or on state is defined as 100% amplitude, and the 0 or off state is defined as a lower amplitude. As mentioned a few moments ago, the lower amplitude can be either 0 amplitude or some non-zero amplitude, as shown in the diagram here. The case in which we have a 0 lower amplitude is sometimes referred to as on-off keying, since we're essentially turning the carrier on and off. As shown by the graphs, a logical 1 is full amplitude, and a logical 0 is no amplitude. This is probably the easiest of all the forms of digital modulation. In traditional Morse code communications, the modulator is nothing more than a human hand. However, this transition between off and on states also has some potential disadvantages. It's more stressful for amplifiers and some other types of RF components, and the rapid rise and fall times can create undesired effects, such as spectral regrowth. One application that uses both types of amplitude shift keying is near-field communications. NFC specifies both variants for use in the uplink. NFC Type A uses on-off keying, or so-called 100% ASK, and NFC Types B and F use 10% ASK. All the examples of ASK that we've looked at so far show two levels, but it's possible to implement ASK with more than two levels. This is sometimes called M-ary ASK. For example, here we see the carrier taking on 4 different amplitude states. Each level corresponds to one of 4 different states, and each state can represent 2 bits. The use of more than 2 ASK states is, however, rather rare, largely due to the fact that noise can create more frequent bit errors as the number of amplitude states increases. So in summary, amplitude shift keying conveys digital information by changing the amplitude of the carrier in discrete steps. ASK is used in numerous applications, including Morse code, many types of wireless remotes, and NFC, or near-field communications. In almost all cases, ASK systems have two states: a high state that corresponds to 100% carrier amplitude, and a low state that is less than 100% amplitude. This lower state may be only slightly lower than full amplitude, or it may involve turning the carrier off completely, something called on-off keying. On-off keying is popular because it's very simple and inexpensive, but it can also lead to wider signal bandwidth or spectral regrowth, and complicates the selection and design of amplifiers. This concludes our presentation, Understanding ASK. Thanks for watching.